Hello viewers, welcome back to SmartFlix TV. Today we'll be talking about introduction to Indicial Equation. In our previous class we talked about indices. I gave us some of the simple examples on indices and I went forward to solve some other questions on indices. Today I want to introduce Indicial Equations. Now, indicial equations are also known as exponential equation. Now, let's say for example you have x raised to power 2 is equals to 4. This is an example of an indicial equation. This kind of equation, what we do most of the time is that we equate them and we cancel the ones that we can cancel, then we'll get the value of what we are looking for. Take for example, you are given this kind of question. How do you solve it? Now let's go. You make an index of 4 with a power here 2. So it becomes a make index of 4 with a 2. This will give you x power 2 is equals to 2 raised to power what? 2. The 2 will cancel the 2. Then x equal to 2. It's as simple as this. Another simple example we can come across is when you have x raised to power 4 is equals to 16. When you come across something like this, it's simple. They are equating each other. So what you do, you just say x raised to power 4, make an index of 16 with the 4. You become 2 raised to power what? 4. So that the 4 will go. So you have x power what? 2. These are simple indicial equation. Like I said, we are introducing indicial equation. After we finish this class, in the next class, I'll be taking further examples on indicial equation. Now, this is example 1. This is example 2. Let me take example 3. Now, supposing you now have x raised to power 1 over 2 is equals to 4. Yeah. Look at this one we did. This one was x raised to power 2 equals to 4. What we do is simple. We cannot do what we did in that first place. Now, what we now do is that we'll look for a number that by the time this half is cancelled, it will affect the 4 here. Now, you have 1 over 2. If you multiply 1 over 2 by 2 over 1, by the inverse of what you have, the 2 will cancel the 2, it becomes 1. So this one has been reduced. So what you have here, you multiply by inverse of your power. So in this case, we have 1 over 2. The inverse will be 2 over 1. So it becomes x, you multiply 2. 1 over 2 times 2 over 1 is equals to 4, 2 over 1. You multiply both sides. So this 2 will cancel this 2. So you have x to give you 4 raised to power what? 2. X, 4 raised to power 2 is 4 times 4, which will give us 16. Are we clear? Yeah. The next one. Supposing you have 2 raised to power 2x raised to power 3 is equals to 54. This one is also simple. We'll remove the coefficient of x cubed here first, so that we'll be dealing with just the s. How do we do that? You multiply both sides by 2. Sorry, you divide. Let's divide, sorry, because we are removing the 2. If you divide, it becomes 2x over 2 is equals to 54 over what? 2. 2 will go. So you have your x. This will give you 27. Okay, raised to power 3. 27 raised to power 3. Now, once to remove the 27, So they want to remove the cube. It becomes 3 times 1 over 3 x is equals to 27 1 over what? 3. We are multiplying by the inverse. This will cancel this. So x, this one becomes 27 1 over 3. We are now on indices again, where we dealt with fractional indices. So in this case, it becomes 27 multiplied by 1, then cube 3. This will give you 3 root, then the 1 outside. So that the 3 here will cancel the 3 here outside. So you have 3 raised by 1, which gives you what? 3. That's your example 4. Next, we'll take the number 5. Three raised by 1 is equals to 3. Therefore, x is equals to 3. Are we clear here? Now, number 5. If you have 4c minus 1 is equals to 64. 4c minus 1 is equal to 64. What I mean 4c, I say 4 raised by c minus 1. It's not 4c multiplying each other directly. So in this case, you have 4c minus 1 is equals to, look for a number that when you multiply it, the base will be 4, so that the 4 can cancel each other. So here becomes 4 raised by 3. 4 times 4, 16. 16 times 3 will give you 64. So that the base will go, it remains the index or the power. So you have c minus 1 is equals to 4. C is equals to 4. You take the minus to the other side, you change to plus 1. So your c is equals to what? 5. Okay? Let's take another example. Example 6. You have 2r minus 1 is equals to minus 16. Sorry, 2r minus 3 is equals to 16. This one is just like this one here. They are similar. So what do? Divide through by 2 here. This is the equation of r minus 3. We divide through by 2. So what do you get? You have minus r, you have r raised to power minus 3 is equals to minus 8. Now, let's make an index of 8 so that we can cancel this one here. So it becomes r minus 3 is equals to minus 2 raised to power what? 3. Okay? So that the 3 will cancel the 3 here. So what we're having here is r minus 1 is equals to minus 2. So in this case here, we'll just go like this. 1 over r is equals to minus 1 over what? 1 over r is equals to minus 2 over 1. So what do you have here? You have a fraction here, another fraction here. They are separated by what? An equal to. You cross multiply. If you cross multiply, you'll be having a minus 2r is equals to 1. So that r will give you minus 1 over 2. Okay? Let's drop the ball so that we can continue. Okay? Now, if we have another example, x plus 7 raised to power 3 is equals to 27. Still the same thing. In this case, this is number 7. You have x plus 7, 3 will give you 3 raised to power what? 3. So that the power will equate each other and they will cancel. So you have x plus 7 is equals to 3. This is a linear equation. So we remove the 7, take it to the other side. You collect like terms, so it becomes x is equals to 3 minus 7. So x is equals to minus 4. Okay. The next question, number 8. If you have 3 multiplied by 5x plus 4 over 25x is equals to 375. You don't need to panic when you see things like this. Okay? All we just need to do is to look at the place where we start from. Now, how do we commence? It's simple. We have a 3 here. We have 25. 5. 375. Let's let me see. Okay, it's simple. Let's equate it over 1 and let's cross multiply to make it easier. This one is a fraction, this is also a fraction. You can cross multiply. When cross multiply, what do we have? You'll be having 3 times 5 x plus 4 is equals to 2 5x times 375. Okay. Okay, let's proceed. Let's remove the 3. So we have divide by 3. Let's divide by 3. Here we go. You have 5x plus 4 is equals to 25x times 3 here 1, 3 here 1, 3 here will give us 2. And we have 1 left. 3 and 15 will give us 5. So you have here 125. Okay? Now let's move on. This is what you have here now. You can now look at it and bring all this one to this side. So in doing that, what do we get? This will give you 5. Okay, let's divide through by 25 raised to power x. We'll cancel this one. So you have 5 x plus 4 over 25x is equals to 125. Okay, so that's what we have here. It becomes 5 x plus 4 over 5 2 x is equals to 5 3. Now from this place here, we cannot have it to be like this. 5 x plus 4 is equals to 5 3 times 5 2x. I cross multiply it again because I'm seeing another similarity there. When I do this, what am I getting here? I will now have 5 x plus 4 is equals to 5. Take one of them, it becomes 3 plus 2x. Yes, we are there already. The 5 and the 5 will go. So you have x plus 4 is equals to 3 plus 2s. Collect like terms. You have x minus 2s is equals to 3 minus 4. X minus 2s is equals to minus 1. 3 minus 4 will give you minus 1. X minus 2s will give you what? Minus x is equals to minus 1. Minus will cancel minus. So you have x equals to what? 1. Okay? We have solved 8 examples now. I'll be giving us another example to make it 9. And after that one, I would end the class. So that in our next class, I'll be bringing in more complex indicial equations. Okay, let's take it. We have 3 2x minus 12 times 3x plus 27 is equals to 0. Now, like we said initially, we said we are introducing us to indicial equation. And we said indicial equations are equations that are exponential equations. And when you have an equation, majority of the time, they are equated to 0. And this is a typical example of one of them. Okay? Now let's proceed. This case here, you have 3 raised to power s here. Here you have 3 raised to power 2s. So let's make these two similar so that we can equate it. So we say let 3 raised to power s is equals to what? Y. Let's convert this. This one here is 3 raised to power 2s. We can turn it to power of power law. This one remains, can still be written as 3x raised to power what? 2. They are still the same thing. So with this, we can now eliminate 3 raised to power 2x. So it becomes y squared minus 12 times y plus 27 is equals to 0. Because this 2s has been replaced by 3x raised to power what? 2 outside. So now we have y squared minus 12y plus 27 is equals to 0. Okay? Now, this has led us to quadratic equation. Though I have not taught us quadratic equation, but I have to explain this. Now, when you see a quadratic equation like this, there are methods you can use to solve it. Number 1, you can use quadratic formula. The quadratic formula. Number 2, we can use factorization, which is the simplest. Number 3, we can use completing the square method. All these I will treat when I start dealing with quadratic equation. Number 4, you can also use a graphical method to solve this. Under while conditions, this question is always there and it's 12 mark. So if you know it, you are good to go. Now let's progress. Y squared minus 12y plus 27 equal to 0. Whatever method you used with this 4, you will arrive at the same answer. But I told us, I said factorization is the simplest. And for this class, I think we should just use it so that we can just progress. Now how do you factorize? You have y squared minus 12y plus 27 is equals to 0. We have what we call coefficient. Coefficient of x squared, coefficient of y squared is a. Coefficient of y is b. Constant term is here c. Now what's your coefficient of y squared here? Is 1. Coefficient of y is minus 12. Your constant term is 27. The simple method I use is just like this. You say a times c will give you b. A times c, 27. That's 1 times 27. Okay, when you do this one, we said it must give you what you have in b. 1 times 27 is 27. How will 27 give us minus 12? It's simple. We are going to factorize 27 to give us 12. Two numbers that will give us 12. Now, let's progress. We have 1 and 27. We have 3 and 9. Any other number? Let me look at it here. 27, 3, 9, 3, 3, 3, 1. Yes. So it will be, we can use this method. It's 3 times 9, 1 times 27. Those are the two factors, yes. So these two values we have here, which one of them will give us 12? That will be 3 and 9. 1 and 27 can never give us 12, no matter what you want to do. But 3 and 9 will give us 12. Now, we needed a negative 12. A negative 12. So what do we do? You go minus 3 and minus 9. Minus 3 and minus 9. What will it give us? It will give us minus 12. And if you multiply minus 3 and minus 9, it will give us what? 27. And that's how we said A times C must give us what? B. And if that's the case, we're almost done. Okay? Now let's see here. We'll come back to this place. It becomes y squared minus 3y minus 9y plus 27 is equals to 0. So we are removing the 12 so that we can factorize it to get a value. So these two together. So we have y squared minus 3y, we bracket it, minus 9y plus 27 is equals to 0. We factorize y minus 3. Take out this one, you have what is common here? 3. Pull out the minus also. Here becomes y minus 3 is equals to 0. The reason we are pulling out the minus is because when you pull out the minus, if you multiply the minus by this 3, it will give you 27 with the 9. But if you don't pull out the minus, it will be giving you positive value. Also, this one in the bracket here must be the same. If they are different, it means your answer is wrong somewhere. So what do we do here? You take one of it, because we said factorizing. The y minus 9 gives you what? 0. Okay? At this point here, we'll come back again. And we'll say either y minus 3 is equals to 0 or y minus 9 is equals to 0. Either of them will give you 0. So in this case, you have y minus 3 is equals to 0, so that y is equals to 0 plus 3. So y is equals to what? 3. Or y minus 9 is equals to 0, so that y is equals to what? 0 plus 9. Y is equals to what? 9. So you have two values for your y. But your y is not in the equation. This is your equation. Your equation is in terms of what? S. So simply, we have it here. They said let 3x equals to what? Y. So wherever you see your y, put the y you get in the one you solve. So you have here to be 3. You say when y is equals to 3, then 3x is equals to 3. Put 1 on top of it. They are similar. This will cancel this, so you have x equals to 1. When y is equals to 9, 3x is equals to 9. 3x is equals to 3 raised to power 2. 3 cancel 3, so your s is equals to 2. Therefore, your s is equals to what? 1 and 2. These are the factors of this equation, and that is the solution to this indicial equation. Okay? What this is telling us is that if you put the value of x to be 1 inside this equation, and you put the value of x to be 2 inside this equation, you must get 0. It also means that this is the only solution to this particular problem. Any other solution, maybe x equals to 5, 6, 7, they do not solve this question. So this is where we are going to end the class for today. I appreciate the time you've spent with me. Thank you very much.